Okay, hi everyone. Good morning for Zeta. Okay, today we want to learn chapter 8, measure of dispersion for ungrouped data. Okay, so this is what you have learned before. So you have learned what is actually measures of dispersion, and then compare and interpret dispersion. Okay, based on stem and leaf plots and dot plots, and make conclusion. You dah buat yang ni. Okay, next. Determine the range. What is interquartile range, variance, and standard deviation as a measure to describe dispersion of an ungrouped data. Okay, number 3, you have learned how to explain the advantage and disadvantages of measure of dispersion to describe ungrouped data. And then last but not least, construct and interpret the box plot. Okay, so this is the last exercise that you have done. So box plot. Okay, so next for today's objective, okay, we want to determine the effect of data changes on dispersion based on the value of measure of dispersion and the graphical representation. So we will look into the effect of data changes. Okay, then number 2, we want to compare and interpret 2 or more sets of ungrouped data based on the appropriate measure of dispersion and hence make conclusion. We will see this. And then number 3 is solving problem involving measures of dispersion. Okay, so this is effect on data changes. Okay, so first, there are no changes to the measure of dispersion when each value of set of data is added or subtracted by a constant. Means every data is being added or subtracted by a constant. Constant is a value, new value. So there are no changes. This is the effect number 1. Okay, effect number 1. So effect number 2, okay, so when each value of a set of data is multiplied by a constant k, then, okay, so bila dia multiplied, so the constant, if you want to find the new range, so it is time of the original range, the first original. So when you have new interquartile range, so that means k times original interquartile range. Standard deviation is the same. So times dengan original standard deviation. But for the variance, okay, variance you know is the symbol is like this. So means the constant is k square. Okay. So when each value of a set of data is divided by constant k, then when it is divided, then everything is also being divided except for the new variance, which is divided by k square. Okay, so what are the effects on the measure of dispersion when an outlier is added or removed from a set of data? So what is an outlier? Outlier is a new value that is out of range. Okay, so either it is a minimum value or maximum value. One value saja yang ditambah atau dikurangkan daripada data set yang sedia ada. So what will happen to the range? So the range will change dramatically, okay, because of outlier to maybe added or removed from the set of data, and then it will change. So for interquartile range, the interquartile range is less affected, okay, when an outlier is added or removed from the set of data. Okay, C is variance and standard deviation. So what happened to the variance and the standard deviation? So the variance and standard deviation will increase if outlier is added. So then when you have the difference between the new value of the data and the mean is small, okay, difference between the new value and the mean is small, then the new standard deviation will be smaller. Vice versa means if the difference between new value of the data and the mean, okay, is larger, so the new standard deviation will be larger. Then if the difference between the value that is removed and the mean is small, so this is added, this one is removed. So when the value that is removed and the mean is small, so means the difference between that is small, then the new standard deviation will be larger. So this is a different case for when an outlier is added or being removed. Okay, how do you determine the effect of data changes on dispersion based on graphical representation? So the effect of data changes can be graphically displayed by using dot plot and stem plot or block box plot. Okay, so this one is when it's already in secara graphic. One is how you discuss if you have been given a set of data. This one is graphically. So means here is the dot plot. So you have the range is between 8 and 15. Okay, so then what is happened if each value set of data is added by 2? So means added by constant, what will happen? So everything change. So from 8 you plus 2 you akan jadi 10. So start dekat sini lah. So 9 plus 2 and everything is being added by 2. So means the same constant that will be applied to each set of data. So you will get the new set here. But we compare the original score range is 7 and the new score range is also 7 because it is added. So this explain how if the constant is being added, so no change in the range. Okay. Okay, so now the data is changed uniformly by multiplying or dividing by a constant. So what if each value set of data is multiplied by 2? So 1 times 2, 2 times 2, 3 times 2, 4 times 2, 5 times 2, 6 times 2, times 2 times 2 lah. So okay, so sampai sini sebab dia tak ada, so tak payah. So 6 times 2 is 12. 6 times 2 12 pun tak ada, so 5 times 2 lah. So here you see the number of frequency. So 1, 3, 5, 4, 3. So you check dekat sini. 1 times 2, 1. And then 3. Okay, 3 times 2 is 6. So you got 5 frequency here. So 4 and 3. So basically it is the same. Okay, but only multiplied by 2. Okay, so what happened? Original score range is 5 minus 1 equals to 4. But the new score range, the maximum value is 10. And then minus with the minimum value is 2. So given you 8. So that's why when each value of a set of data is multiplied by a constant k, the measure of dispersion will change. Okay, so number C, case C, what if the value added or removed is an outlier? Okay, outlier means only one data being added or being removed. So in this case is when it is added. So currently what you see over here is the minimum value is 1 and the maximum value is 5. So when number 9, an outlier is being added. Okay, so what happened? is the dispersion of the whole dot plot becomes wider. So original score range is 5 minus 1 equals to 4, and then the new score range would be 9 minus 1 equals to 8. Okay, so the outlier, it depends on the minimum and maximum value. So the measures of the dispersion of the new set of data become larger compared to the measure of dispersion of the original set of data when an outlier is added. Okay. Okay, so self-practice 8.2D. So this is where the interquartile range and the standard deviation of a set are 6 and 3.2 respectively. Calculate the new interquartile range and the new standard deviation if each value of the set of data is added by 4. So do you have to count this? I don't think so, because of, okay, even though the question is calculate, you must give justification. Why? Because if each value, because this one is every value of the set is being added by 4, say basically there is no change, right? So how we answer to this question? So means the new interquartile range is 6 and the new standard deviation is 3.2. Why? Because the values are unchanged since every each of data is added by 4, which is it is a constant. So please remember, when a constant is being added or removed to a set, every set, or being subtracted, added or subtracted by a constant to each set of data, so the interquartile range and the standard deviation will be unchanged. Okay, so this is number 2, self-practice 8.2D. So given a set of data 4, 6, 7, 8, 2, 10, 12, 16. So this is apa, already been arranged accordingly. So calculate the standard deviation of a set. Explain the change on the standard deviation if 70 is added to the set of data. Okay, so this is the original. So how to calculate the standard deviation? So standard deviation is like this, right? So you have to find the variance first. So before you find the variance, you must find the mean. So mean, the symbol is like this. Okay, so means 4 plus 6 plus 7 plus 8 plus 10 plus 12 plus 16 is divided by 2, 4, 6, 8. 2, 4, 6, 7, 7, sorry. Okay, sekejap Okay, now the mean is 9. Okay, so the variance is the total of every set of data divided by n. So we find the formula first. Minus, okay. So here is 4 square plus 6 square. Okay, then you will be having So the standard deviation is 3.7417. Okay, now we compare if an outlier 70 is being added. So now the new mean is outlier 70. So it have a new maximum range. So divide by 8. So the new mean is become larger. So 16.625 compared to the original mean. So now the standard deviation, so kita pakai yang ni je lah, sum of the square of each data divide by the n or the sum of frequency minus the new mean square. Okay, so this is standard deviation. Plus 70 square over 8 minus 16.625 square. So I dapat 20.4752. Okay. Explain the change on the standard deviation if 70 is being added. So maka therefore the standard deviation becomes larger when the outlier being added to this set of data. So this is the how to explain the standard deviation. Why? Okay, because you can see 70 is much larger. Okay, out here is being added. Okay, now this is objective number 2. How do you compare and interpret two or more sets of ungrouped data based on the appropriate measure of dispersion? So this is example between time taken for 20 employees in 2 factories to complete a job. Okay, so you got factory A and factory B. Now, calculate the mean and standard deviation for the time taken to complete the job. Hence, determine which factory's employees are more efficient to complete the job. So, you must compare it with the time, the hours. So, means they start with the minimum value, which is 5 hours per 20 so per person lah. So this one is 5 hours until 9 hours in a day to complete a job. Okay, so the mean for factory A, so you look here 32924. So the mean here is times first. Okay, you time everything. So if like this, it different, so you do the mean, do the formula, which is the sum of fx over sum of f, for if you be given a tabulation. So this one is frequency. So bawah ni lah frequency. So this one is time lah. So you just times everything. So you got the mean, and then the check balik. So here is the sum of frequency, 3 plus 2, 5, 14, 16. So you dapat 20 dekat sini. So 20 you masuk di bawah. So here you time everything, and then you got the mean is 7.1. So the standard deviation, if where the 5 square the time, so atas ni kena ingat kalau standard deviation, so dekat T yang kita squarekan dia. Don't square the total of frequency. So 5 square times 3, then 6 square times 2, 7 square times 9, 8 square times 2, and 9 square times 3 times 4. Divide by n means 20, and then you minuskan dengan 7.1 square. So you got the standard deviation is 1.261. Okay, for factory A. So untuk factory B, okay, the mean is fx divided by n. So you got 7.1. Is it the same? I think it is the same. Sama dia punya mean. Okay, so and then the standard deviation is you got 1.044. So means compared to factory A is 1.261. 1.261. Yang ni is 1.044. So means it lesser than 1.6 tak ingat lah. 261. 261. Okay, so meaning we select factory B. So because the standard deviation is smaller, reliable compared to if you got the standard deviation is high. Okay, sama juga macam new set of data tadi, compared tiba-tiba if outlier 70 is being added, now the standard deviation is become 20. So it is not reliable. Okay, number 3, which is solving problem. So here we have two groups of pupils. So group A and group B. What you've been given is number of pupils and the means and their variance. So mean here you apply, and then here is the variance. Okay. And then all the pupils from group A and group B are combined. So combined is plus, and then determine the standard deviation of the mass of the combined groups of pupils. So they want the standard deviation. Okay, so the formula is the standard deviation is the square root of sum of x square every set of data divided by n minus mean square. Okay, so you've been given a mean for every group, and then you've been given a variance for each group. Now you want to get the new standard deviation, so you must get the new mean and new variance. So for group A and group B, so kena asingkan dululah. So group A and then group B individually supaya kita boleh combine. Okay, so mean here, so kita tengok dulu mean. Mean equals to the sum of x over n. Sebab kita tak tahu, because we don't know what is the sum of x. This is really important. So here the sum of x over n is 18. X mean is 52. So means the sum of x kita dapat 52 times 18, which is 936. Okay, we compared here. So now group B pula. So x, the mean. So this one is A lah. This one is B. So the sum of xb over n. So which is the sum of xb is equals to 56 times 12. So you akan dapat 672. Okay. This one is A. So the new mean, which is x. Okay, sebab tak ada apa-apa kan. So here is when you combine. Now you can have 936. You plus dengan 672 over n equals to 30. Okay, so kat sini lah plus. So the number of people, which is the total of frequency, equals to 18 plus 12 equals to 30. So di sini over 30, and then you will have the mean is 53.6. Okay, so this is the new mean. And then we must calculate. Sebab kat sini kita n ni yang baru kita tahu 30. This one we already know. The mean here is 53.6. Tapi nak cari balik dia punya the sum of every set of data. You muat tak? So group A. Now the variance. So this is the formula. So using the formula for both group A and group B, we identify what is the total of the x square for each of data. So here is the variance. Variance is 2.5 equals to yang ni kita nak cari. Okay, sebab nanti kita nak combine. So A lah saya letak kat sini over n is 18 minus dengan mean is 52 square. So I got here. Okay, so kita tambah dulu kat sini kan. So 2.5 plus 52 square. And then you times dengan 18 times 18. Akan dapat 48,717 for the sum of square data. So for group B pula, group B, the variance is 1.8 equals to the over 12 minus 56 square. So now I dapat 1.8 plus 56 square, and then I times dengan 12, and then I got 37,653.6. Okay. Now the standard deviation. Okay, so standard deviation kita letak kat sini lah formula dia. Okay, total x square over n minus mean. Okay, so here ada for the new one is 30 and then I minus dengan mean is 53.6. 53.6 square. So you akan dapat the new standard deviation is 2.4617. Okay lah. So the standard deviation of the mass combined is 2.46. So maknanya kat sini kalau you tengok variance dia, so what is the standard deviation kat sini? 1.58. This one is 1.34. So it means the new standard deviation is larger for the mass combined compared to their alone lah. Okay. Okay, thank you. So now you may continue with your exercises. Terima kasih.